In this video, I want to talk about the big idea, or an appropriate conceptualization of division, and that is grouping as a big idea. By big idea, I want to emphasize that this language, the emphasis on grouping, should be carried on throughout the time that students spend learning division, which spans from 3rd grade through 6th grade, starts in 2nd grade with understanding groups, which incorporates the big idea. The reason grouping is important is because there's a common, and I'll get to that, but there's a common misconception, I think, or I certainly see this as a possible misconception of division, that when a student divides 15 by 3 or divides 15 3 ways, I don't think they even get to a point where a lot of kids where they really even understand that they're taking 15 items and they're dividing them into 3 groups. They just see 15 divided by 3 is 5, and they learn that, and 5 becomes the answer. Well, the misconception there is that 5 isn't all that still remains. There are still 15. When you're grouping, when you're dividing, there's still 15 items that remain. The focus of one group is just 5. You're finding out how many items are in one group if you divide it up or separate it into 3 different groups. So grouping, I think, is a better way, is a good conceptualization, and I'd actually have my kids, and I've designed an intervention this way, where you actually start like this. When you divide 15 by 3, and I wouldn't necessarily start with that representation. I might start with a representation like this, but either way, eventually they need to learn this symbolic language too. But if I'm taking 15 divided by 3, that means I'm taking 15 and I'm dividing it into 3 separate groups. So I think it's valuable at least to have kids just start counting out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So they've separated all 15 of those items one at a time, kind of like dealing cards, into 3 groups, and the answer is 5. So what they see through grouping is that those 15 items are still there. I've just identified how many are in one group. So 15 divided by 3 answers the question, how many items will be in one of the 3 groups? And this is an important component for problem solving because, consider this scenario. You have students who are going to shovel sidewalks during the winter. 3 students, probably they are students, but maybe 3 kids join together. They get some snow shovels and they're going to shovel driveways during the winter time, and they shovel a smaller driveway and they get paid $15. How much money will each of them take away? They'll each take away $5. That's an easy problem, but the $15 still exists. And see, the misconception, I think, comes in equating this with subtraction, that at the end 5 is all that's left. But when we're dividing, that's not the case. We still have the original 15. We're just determining how many are in one group. Now, a kid goes to the store and buys a Coke for $2. Now we're subtracting. He only has 3 left. That $2 now is actually gone. So the misconception, I think, is equating division with something like subtraction. And that's just simply not the case. And I'm suspicious that may be why students have so much trouble with division, especially when it comes to problem solving and applying the correct procedure for problem solving when the correct procedure is division. So that's why this emphasis on grouping, I think, is really, really important. And I would do simple things like, I wouldn't even start with 15 divided by 3. I'd start with 9 divided by 3. And then 9 divided by 3 means I'm going to take 9 items and I'm going to separate them into 3 groups. So, and I would just have kids count them out. 1, 2, 3, 4, 5, 6, 7, 8, 9. Or lay 9 counters out on a table and say put them into 3 groups. That probably is a better way to start. That's a good way to start at the lower levels, so they have a concrete modeling. But then I think, as they get that down, this more pictorial modeling is just a good activity, and you don't want to do it forever and ever because it takes too long and it quickly becomes inefficient. Like if I want to divide 54 by 3, well, that's going to take me quite a bit of time. It's not an efficient way to do this. But I do it enough so that students understand this grouping aspect. And again, the emphasis that you're making with this, I believe, is that nothing goes away. I'm dividing these 9, I'm reorganizing these 9 items into 3 different groups. And then the answer, the quotient of that is 3, which answers the question, how many will be in each group? And then I would contextualize, like the snow shoveling problem that I brought up just a second ago, but use things that your students or your children would understand, that's within the context of their life, something they can connect to easily. Because there's a lot of connections happening here. There's the visual, there's the contextual connections, which are going to help, and they're very simple, so kids will grab onto these easily. So it can be counterintuitive to think this is powerful, but the power in it is the simplicity allows them to learn it quickly. It allows them to learn it solidly. It's going to encode that information into long-term memory in visual ways, in contextual ways as they remember, as they think about the stories of shoveling snow or whatever you decide to make up. And this creates multiple connections and multiple pathways to the process or procedure of division that'll help when it comes to problem solving. Because when they problem solve at a higher, more elaborative level, what happens is the brain starts to search for similarities, for things that it's encoded, not from its, well, yes, from its past, but for items of knowledge that it's encoded, memories that are encoded now into long-term memory. It's going to start to search for something that's similar. So the more, it just makes sense that the more connections you've made, the quicker and the more likely the students are to find the right connection to help them solve that problem. So big idea in division. It's also the big idea in multiplication, but honestly I think it's probably more powerful in division because of the common misconceptions that come from that operation.